explorers are sending back frightening information to Earth. The Explorer 1, NASA's farthest voyage space apparatus, is still traveling across revealed districts of the universe almost 50 years after its launch. Researchers are bewildered by the alarming data that this popular space probe is sending back to Earth, which seems to be due to a glitch. Join us as we discuss the strange information that the Explorer has been transmitting during its troubled space exploration. Researchers have been intrigued by the domain beyond since the Big Bang, which propelled the launch of Explorer 1 and Explorer 2 among other space missions. Explorer 2 was, in fact, the first rocket to launch from the NASA Kennedy Space Center on August 21, 1977. On September 5 of that very year, Explorer 1 was launched about 14 days later. However, how did they switch places as twins? The weight of the two probes is around 720 kilos, about the same as a small vehicle. Both were launched during a window of special outer planet alignments that caused a slingshot effect to propel the rocket from one planet to another. They have, however, needed to move at different rates and in different directions. On December 15, 1977, Explorer 1 was able to pass its identical twin. Since then, it has been our go-to resource for learning about various cosmic mysteries. The primary shuttle to do so was this one when it began its Jovian imaging mission in 1978. It was about 265 million kilometers from our planet and sent a massive number of photos back to us. Explorer 1 completed an extraordinary 108-hour spell starting in January 1979, during which it captured 3,750 images of Jupiter's rotation to produce a time-lapse film showing 10 of the planet's turns. It had gone through the Jovian moon system in February 1979, and after a month, it had discovered the small ring surrounding Jupiter. Explorer 1 also made a special revelation when it found two new moons named Phobos and Deimos. Moves were made to ensure that the spacecraft was ready for its flyby of Saturn and to prevent a potential collision with Titan, one of Saturn's moons. Explorer 1 also discovered 4 additional moons during its orbit around Saturn, including Mimas, Enceladus, Tethys, and Dione. Researchers chose to halt the Explorer planetary mission after the Saturn mission was completed and sent both Explorer 1 and Explorer 2 beyond our solar system at a speed of 325 million miles each year. In January 1990, the new mission, officially known as the Explorer Interstellar Mission, began. Some of the most renowned photos in history, depicting the Sun and the majority of the planets, were taken by Explorer 1 on February 14, 1990, while it was 6 billion kilometers from the Sun. These images are often referred to as the Solar System Family Photo. There were 60 total shots taken by Explorer 1, bringing the total number of photographs taken by the spacecraft to 670. However, Mercury and Mars were not visible in the photographs due to multiple factors. Eventually, the spacecraft's cameras were turned off to conserve power and memory before its journey into interstellar space. In addition to the interstellar probes Explorer 1 and Explorer 2, NASA also operates the Pioneer 10, Pioneer 11, and New Horizons spacecraft. Before Voyager 1 passed by Pioneer 10 on February 17, 1998, Pioneer 10 was the farthest spacecraft. Explorer 1 continued its journey for a further 14 years before it finally entered the interstellar environment on August 25, 2012, with no other space probes in sight to explore. NASA did not publicly announce the achievement until 2013. Let's move to November 2018. Both space probes had officially left the solar system when Explorer 2 crossed the heliopause and entered the interstellar medium. Explorer 1 is thought to be 145 billion miles or 550 million kilometers from Earth. It has continued to provide us with significant data that no other space probe missions have been able to reveal since it entered the unseen realm beyond our solar system. The spacecraft has spent the majority of its 45-year journey in space in good health. However, recently scientists have discovered some odd anomalies in its performance. Explorer 1 is currently sending cryptic signals back to Earth, giving the impression that it is uncertain of its position. However, there is a disturbing twist to the issue. Typically, scientists have pre-programmed Explorer to go into experimental mode or sound an alarm if it gets derailed in space. Yet so far, it has not. Furthermore, its antenna, which sends information back to Earth, appears to be in excellent working order, yet the data it has recently been transmitting is ambiguous. The interstellar traveler is operating normally, taking instructions from Earth and executing them, as well as gathering and sending scientific data. However, readouts from the probe's articulation and control systems do not accurately reflect what is happening inside. According to a NASA official statement, what exactly is going wrong? Each spacecraft that is heading towards interstellar space, including Explorer 1 and 2, has a unique 12-inch diameter gold-plated disc that is loaded with sound and video messages as a backup in case an alien species finds the vessel. The disc contains 35 Earth sounds, 115 live photographs, 90 minutes of Western music, and greetings from former U.S. President Jimmy Carter, as well as former UN Secretary General Kurt Waldheim. These are only a few of the items on the space DVD, which are kept in 55 different languages. If it were taken over by aliens, they would likely be attempting to interpret the signals. The notion that the spacecraft is currently under the influence of aliens has been swiftly disproven by scientists. Explorer's ability to function depends heavily on the attitude and articulation control systems. First of all, it always maintains its antenna focused on Earth so that researchers can accurately receive information. It also controls how the spacecraft is oriented. Engineers monitoring the situation currently believe that the attitude control system is functioning as it should, which only adds to the puzzle we now face. None of the safety features designed to protect the spacecraft from danger have been activated by Susan Dodd, project manager for Explorer 1. Such a mystery is interesting, especially at this point in the Explorer mission. The spacecraft are both around 45 years old, which is much older than what was envisioned in the mission plan. Dodd also acknowledges that the spacecraft's engineering team will face significant challenges in resolving the issues with Explorer 1 due to the distance between us and the probe. The challenges are considerable, largely because the spacecraft is approximately 145 billion miles away from Earth. This enormous distance presents several difficulties that the team must navigate carefully. A rescue mission is nearly impossible given the current technological and logistical constraints. Explorer 1 is far beyond the reach of any spacecraft or repair mission that we could plausibly send. The spacecraft's complex journey has brought it into the outskirts of our solar system and beyond, into interstellar space, where it continues to travel further away from us every day. Messages sent from Earth at the speed of light take nearly 21 hours to reach Explorer 1's current location. This means that any command or guidance sent by the engineering team takes a significant amount of time to be received by the spacecraft. This delay poses a major challenge for real-time problem-solving and troubleshooting. Furthermore, once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to return. This implies that two-way communication between Earth and the spacecraft takes an average of 2 days. Such a delay makes it extremely difficult to implement practical solutions or iterative troubleshooting processes, which are often crucial when dealing with complex technical issues. The engineering team must carefully plan and execute each command, anticipating different scenarios and potential outcomes. Unlike missions closer to Earth, where engineers can quickly send and receive commands, the long communication delay requires a more strategic and patient approach. Every instruction must be meticulously crafted to address the known issues without causing additional problems, considering the extensive time it will take to confirm whether the command had the desired effect. The significant communication delay also means that the engineering team has limited opportunities to interact with the spacecraft. Each command sent must be effective and precise, leaving little room for error. This requires extensive testing and validation of commands on Earth before they are communicated to Explorer 1. In addition to these logistical challenges, the spacecraft itself is over 40 years old, having been launched in 1977. The technology on board, although cutting-edge at the time, is now considered outdated by modern standards. The engineering team must work with equipment and systems that were designed and built during the 1970s, which adds another layer of complexity to the troubleshooting process. The harsh environment of space also takes a toll on the spacecraft systems. Explorer 1 has been exposed to cosmic radiation, extreme temperatures, and micrometeoroids for over 45 years. These factors contribute to the wear and degradation of its components, making it even more challenging to maintain and repair. Despite these obstacles, the engineering team remains committed to resolving the recent concerns. They are investigating various theories about what may be causing the anomalies and testing potential solutions through simulations on Earth. This careful, methodical approach is essential given the stakes involved. Any incorrect command could potentially disrupt operations or lead to a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Explorer-1 systems, like many other space missions. Explorer-1 was designed with backup systems to enhance its resilience to failures. The engineering team may be able to switch to these backup systems and restore normal operations if they determine that a specific component is failing. In summary, while the challenges of diagnosing and fixing the issues with Explorer-1 are immense, the engineering team is leveraging their expertise, experience, and the spacecraft's design to tackle these problems head-on. Their work highlights the extraordinary nature of space exploration and the incredible engineering feats achieved over the past 50 years. As they continue to unravel the mysteries of Explorer-1's recent anomalies, they are also deepening our understanding of the universe, paving the way for future missions, and inspiring the next generation of explorers.